explore some opportunities in reducing embodied carbon. I'm Gina Johnson, Director of Programs at Sustainable Pittsburgh, and with me are Program Manager Sarah Sangiovanni and Projects and Events Coordinator Meredith Bennick working behind the scenes today. A quick note, this session is being recorded. So next slide, a little background about the nonprofit Sustainable Pittsburgh. Sustainable Pittsburgh is in our 24th year serving the 10-county region of southwestern Pennsylvania. We work with hundreds of businesses and organizations, as well as communities across the state, to equip them for progress that builds a fundamentally equitable, resilient, healthy, and prosperous region. And among our programs, networks, and initiatives is the CEOs for Sustainability Executive Network that is co-hosting today. So before we get started, we're going to take just a minute, please, to get a sense of your interest in embodied carbon. This is a fun, very easy to use tool, so please don't be scared off from doing it. It's a no app required to download or anything like that. Just go to menti.com. You can do that on your desktop or on your smartphone, and you enter this code at the top of the screen that you see. You're going to see this question and an entry field. Be sure to click submit after you make a selection. We're just looking for a sense of where you are. Do you generally think about embodied carbon in your work? And if these questions don't fit your exact situation, feel free to put it in the chat. So it looks like, some of us are moving in this direction. Maybe some of you are in the types of sectors where you have clients who are interested in doing this. Really great to see that you're thinking about embodied carbon in these projects. Wonderful. Let's give just a second for some more responses. Yep, thinking about it a little bit in your own buildings and your operations. Not really thinking about it at all yet, maybe because of the nature of your organization, but we're hopefully going to give you some more information to equip you today to move in that direction. So that gives us a little bit of a sense. Yeah, thank you. Yep. At least sometimes for product design, that's great. Wonderful that you're thinking about that in your products and services. Just another few seconds for any other responses. Moving in this direction, wonderful. How do I get to the poll? Just go to menti.com. You can do that on your desktop or your smartphone and put in the code there at the top of the screen, 74893842. And it's real easy and quick. You can pop in your selection. There you go. Sometimes for our buildings and operations, this is great. Really happy to see so many of you are already thinking about how to incorporate embodied carbon in your work. Great. Wonderful. Thanks. We'll use this Menti tool one more time during this presentation, so please keep that open and available for some more conversation. We're going to use that to drive the panel discussion later. Moving on now to our agenda, we're really excited today to have some leaders in embodied carbon reduction. All of our presenters are joining us from Colorado. Victoria Herrera Garcia, I'm sorry, we talked right before, and now I'm having stage fright about pronunciation. Victoria, Greg Kingsley, they're both going to describe strategies for getting to net zero in the built environment. And then Jim Valentine is going to join us to follow up, describing opportunities in product lifecycle assessment. After their brief presentations, our moderator, Beth Eckenrode of Oros Group right here in Pittsburgh, will lead Victoria, Greg, and Jim in a panel discussion where we look forward to addressing your questions, barriers that you might be having, any of those in the weeds, things that you want to get into. Please do put any of those questions in the Q&A box in Zoom throughout this webinar. Look forward to getting to those questions. So in addition to our accomplished moderator and presenters, we want to thank our sponsor, Covestro LLC, for helping to make today's event possible. And before I hand it off to the presenters, just a little bit of context. You're probably aware that embodied carbon is the total accumulated carbon emitted throughout a building's or a product's life cycle. Many of you will also be familiar with why it's critical to reduce building emissions if we are to stay within the Paris Agreement goals. In short, buildings represent huge greenhouse gas emissions. We're on track to add the equivalent of an entire New York City's worth of building area to the world every month. And once those buildings are constructed, embodied emissions are locked in. So this is why organizations like the US Green Building Council and the World Green Building Council have moved to zero carbon goals, and why more organizations are looking at it as part of their overall carbon reduction strategies. Maybe they're working towards science-based target or some other carbon reduction goals, and so this embodied carbon discussion is very central or part of that. We know low embodied carbon building is achievable through strategies like reuse, reduce, and sequester. So reusing materials in buildings, reducing carbon through material optimization and specification of low carbon materials, and through sequestering, as through the use of carbon sequestering materials. A 2021 report by RMI demonstrated that we can reduce embodied carbon significantly at little to no additional upfront cost using materials that are widely available today. And here in this study, RMI studied low cost and no cost strategies for reducing embodied carbon during the design and construction phases of 3 types of buildings, and found this finding. Reducing embodied carbon in buildings also has benefits for the bottom line on the next slide, for earning green building recognition, reducing regulatory risk, and improving air quality and public health. Just last month, the White House announced a federal Buy Clean initiative. Many of you may have seen that. This aims to steer government funds for roads, bridges, buildings, military commitment, and other purchases toward low carbon products and materials. In doing so, the administration aims to reshape the market for these materials, driving innovation and investment in the private sector. This is a market that's already growing quickly. The larger green building market is projected to reach $653 billion by 2028. And that's a compound annual growth rate of 10.5%. Likewise, consumer product manufacturers see an opportunity for competitive advantage in reducing and labeling their products' carbon footprints. So according to some recent consumer buying studies, adding a carbon label that showed a below average carbon footprint increased that product's sales, and by a lot if the product was also the cheapest. These studies showed that consumers were also willing to pay more for those products. In line with these findings, more companies are committing to carbon labeling. Companies like Logitech, Adidas, Panera, Allbirds, and Unilever, whose hundreds of brands include Dove soap, Lipton teas, and Ben & Jerry's, to name a few. Businesses can also address embodied carbon by adopting corporate policies to complement existing carbon reduction strategies that they might have. In doing so, they signal to stakeholders that they're taking a comprehensive approach. Businesses that adopt embodied carbon policies are driving demand for lower carbon products, influencing supply chain practices, enhancing data monitoring and carbon reporting, and strengthening the transition to a decarbonized economy. Sustainable Pittsburgh has prepared the briefing document you see there about these opportunities, and you can look for the link to that doc in the email that we're going to send to follow up with registrants after today's event. So now, with these many opportunities in mind, I'm pleased to introduce Beth Eckenrode as today's moderator. She will introduce our presenters and then lead them in some audience Q&A. Welcome, Beth. Beth Eckenrode is the co-founder of AROS Group, which merges building science with data science to cost-effectively reach zero energy, zero carbon, and healthy indoor air quality. AROS Group's secret sauce lies in their proprietary integrated digital twin technology, which demonstrates whether a building is performing as it was designed and constructed to perform. Beth is co-author of the new book, The Power of Existing Buildings, Save Money, Improve Health, and Reduce Environmental Impacts. And she's also a leader in our CEOs for Sustainability Executive Network. Beth?
Great, thank you so much, Gina. And thanks everybody for joining us. We have quite a good lineup and we're going to jump right into it. I'd like to introduce our first panelist, Victoria Herrero Garcia. And Victoria is a Senior Sustainability and Carbon Project Manager for Ambient Energy. And she's also the co-chair of the Carbon Leadership Forum Rocky Mountain Hub. Victoria authored an article for Technology, Architecture, and Design magazine called Whole Building Life Cycle Assessment, Comparison of Available Tools. So I think that is spot on. That is the bullseye of what this conversation, I think, needs to start with. So Victoria, we're so excited to have you here. And I'll turn the conversation over to you.
Thank you very much, Beth. Hello, everyone. I'm going to cover some of what Gina already did with why embodied carbon is important, and then we will jump in like a little further conversation. So Ambient Energy, the firm that I work for, a meat and hand company, is working towards a resilient and regenerative built world. And that is through education, collaboration, and all the different services that we provide. I have highlighted there the whole building life cycle assessment and the net zero carbon consulting, because that is the main purpose of this conversation today. So what the difference is between operational carbon and embodied carbon? Many of you have heard throughout the years reductions in energy loads and operational carbon, and that is pretty much when it happens when the building is already constructed. The embodied carbon differs from the operational carbon in the fact that every material that is going to be to construct that building, it is part of that embodied carbon of that building, and all the decision making happens before, and the embodied carbon will be there for life. It doesn't change after the operational carbon starts unless there's replacements. Kind of like a little graphic of what embodied carbon entails, as Gina mentioned, is from extraction to the end of life of any product using construction or in any like day-to-day life. My part of the presentation and Greg's will be more towards the built environment, but Jim will bring that perspective to the holistic embodied carbon world. The embodied carbon is also known as global warming potential. The unit of measure is the kilograms of CO2 equivalent, and it can include other greenhouse gases, not just CO2. Why it is important? This graph shows the breakdown of global emissions by sector. And if you can see, just by building materials and other building manufacturing, we're counting with a 21%. But when we also add up the rest of the manufacturing that is not related to buildings, we're counting with 43%. Is not half, but is close to half of what we consume and we use in daily basis. As Gina mentioned as well, by 2060 is estimated that the world is going to be building approximately one New York City each month. That is for the next 38 years and 9 months, 465 New York cities. The difference between operating versus embodied carbon and why it's important is that if we do a building as usual, normally the operational carbon will be the biggest chunk of that pie, and embodied carbon will be the smallest. But as we go towards a high performance building and the electrification of the grid, then embodied carbon starts to play a big role. Oops. Also related to climate change and how we are tracking for not exceeding the Paris Agreement goal. This graph has a lot of information. You can read a lot of that in the Climate Action Tracker, the report. But I want you to think about this one, like with the most optimistic scenario, we are going to be reaching that goal, but we need to make sure that we are focusing our efforts on big target reductions in order to meet it. So how does the embodied carbon policy place on these? There is a lot of states and local policies that they are being created and developing every day. This is in the Carbon Leadership's website, in the Carbon Leadership Forum's website, you can find more information about the policies. Other people are motivated by rating systems. And they rewards us by building and material reuse. Other credits and points are by low embodied carbon material procurement, and others about the whole building life cycle assessment. This is a poem by Amanda Gorman. It's called Earthrise. If you haven't seen it, it's in YouTube and it's beautiful. So what she's saying pretty much is like, we refuse to lose. We are here to fight the fight. But how do we do this? We can reduce what we cannot measure. So we need to understand where are the biggest impacts in order to reduce them. There are two ways to reduce, to measure the impacts. One is the procurement of low carbon materials, and the other one is the whole building life cycle assessment. With the procurement of low carbon materials, let me see where it doesn't pass. The first terminology that we need to know is environmental product declarations. Jim is going to cover also more of this in detail, but it's pretty much a nutritional label of our products. And it gives us a lot of different parameters, but one that we want to look at is the global warming potential, which is the embodied carbon of our product. Many of you have heard the system boundary, cradle to grave. So that means from material extraction to manufacturing, and when it leaves the gate of your manufacturing process. Some of you might have heard also life cycle stages. So for the EPD is normally A1 through A3. Some products might have other system boundaries and other life cycle stages included, but for the most part, these are the ones. This is a graphic showing you the life cycle stages, and for the EPD, again, is modules A1 through A3. This is an example of an EPD. It has a lot of information, and it has like the scope, the unit, the declared or functional unit, the global warming potential reporting. So it gets very challenging sometimes to compare to see which product is better than other. The three things that you normally would like to look into to compare them, it will be to have the same declared or functional unit, to if it has the same product category rule and the same systems boundary. So to put it in a easy perspective, there are some free available tools out there that they use the system boundary A1 through A3 and have done all this research for you. So you just need to access the tools and compare products based on all these similarities. Then here are the links to create an account. You will have these available on the recording to go and check them out. And then the whole building life cycle assessment. So this goes a little bit beyond the A1 to A3 stages and the system boundary. So this is a comparison of a baseline against a proposed design case. Includes a system boundary that is cradle to grave. That means life cycle stages A1 through C4, which is from material extraction to disposal. The life cycle stages are here again. The modules A1 through A5, so now includes transportation and construction installation, use stage, and the end of life. So the system boundary cradle to grave and system boundary A1 through C4. Whole building life cycle assessment tools available on the market are the Athena impact estimator, one-click LCA, Tally, and the E-tool. Primarily used in North America are the first three, but they are all available. And here are some of the links to the tools. And then
Victoria, just a quick time check.
Yep, thank you. And some resources also that I'm providing here, links for you. So there is the Carbon Leadership Forum Owners Toolkit and the Carbon Leadership Forums Architects Toolkit. So if you're in the build environment, you can use those toolkits to inform your decision making. And There is also the Carbon Leadership Forum Resource Library, which includes a lot other resources. You can take action to sign in for commitments. There is owner's can that is specific to owners, structural engineers SC 2050, MEP 2040, the net zero carbon building commitments, and there is also a contractor's commitment guide, which includes different categories, but the category number 1 relates to embodied carbon. So how to do anything, just take action, maximize embodied carbon reductions by reuse and reduce, early conversations, setting up targets, low carbon procurement, and include all disciplines always in the conversations. So just open your eyes, the tools are out there, just start the conversations as soon as you can. Thank you very much.
Great, thank you so much, Victoria. That was awesome. And we have some questions coming in, so we're going to wait for those when we convene the panel. But it seems like it's really generated some interest, so that's great. Thank you very much. Great job. We'll switch to Greg. Greg Kingsley is President and CEO of KL&A Engineers and Builders. KL&A is known for vertically integrated services from design through construction. Greg's current passion is for innovative wood solutions and the rapidly growing field of mass timber construction, which I think he's going to share with us as is what he considers the best hope for advancing the environmental responsibility of structural engineering through carbon sequestration. So Greg, take it away.
Thank you, Beth. And thanks everyone for listening. Victoria and I often present together, and she's talked about processes and systems, and I'm going to move on to the next step, which is really about the value proposition. What does all this cost? Anyone who's been involved in these systems or this process knows that the first questions that come up really center around what's this all going to cost me? And I think that we can thank Bill Gates for introducing the concept of green premiums. And his book is a really excellent book, How to Avoid a Climate Disaster. And he said basically the key moral of that story is we need to lower green premiums, which I think is true. But I also think it sort of predisposes people to think that this process always costs something extra. And I'd like to sort of challenge that a little bit in the upcoming few slides. So this is kind of my generic slide about value proposition, about customer loyalty, employee relations, innovation. These are all good things that are bringing value, that drive greater profitability, and then deliver, value to the stakeholders. However, it's kind of generic. I would really rather pose an example, and this is the pictures of the Plat 15 office building, which is a mass timber office in Denver that I'm going to talk about a lot in these 10 minutes. I just wanted to point out that this, office building generated the highest lease rates for commercial space in the Denver area, really just because of its construction and its sustainable story. And it was 85% leased at the time that they got their certificate of occupancy, which was during the pandemic anyway. So some really strong evidence that actually it can bring value. And that owner of that building is actually building another one right across the street to prove that it really worked for them. Another example is the Microsoft campus, where they basically said that they were, just by asking suppliers for lower carbon options, they were able to procure materials that met or reduced their targets for performance at zero cost premium. So it doesn't always cost more. Let's talk about the different building materials. As Victoria said, I'm kind of focused on the built environment and buildings, and hopefully that's okay. We as structural engineers work mostly in concrete and steel and timber. And if I start out with embodied carbon goals, I want to lower the GWP of a concrete building. The main thing I'm going to do is reduce the cement volume. I'm going to increase what they call supplemental cementitious materials like fly ash. Again, trying to replace cement, which is where most of the GWP resides. And all of those moves are going to lower the GWP, and they're also going to lower the cost. If I'm designing a steel structure and I want to lower the GWP, I'm going to basically reduce the steel tonnage and try to increase the amount of reused material or recycled material that I'm using. And those changes may or may not increase or decrease the cost. It's really kind of hard to tell in a generic sense. One of the better but more challenging building types is mass timber, which I'm really taken with building now. I can dramatically lower the global warming potential and sequester carbon in the process of building timber building. But as I do that, the more wood I use, the better it gets and the more it costs. So there's an inverse relationship between the embodied carbon goal and the cost. So with that in mind, I kind of want to focus on mass timber buildings for the moment as the most challenging, I think, of these imperatives. And let me start with just a quick description of where the value lies in mass timber buildings. I always say it comes down to three things. First, mass timber buildings are sustainable. They're the only true renewable building material. That's kind of where we're starting and what this talk is about. But what most people want is a building that looks great and feels great, has biophilic properties. And that tends to be, for my clients, mostly what they're looking for. The other thing that's a dramatic benefit or value is that it builds very quickly, very quietly with very little site waste. So those are the three big values. Now I want to get into a study that we did on that building at Plat 15. That's it on the lower right. This is a study that you can download directly from the ThinkWood website and see all the details of this life cycle assessment and cost analysis. We did both of those things in order to balance what are we paying for embodied carbon benefit. So quick introduction to the building. It's downtown Denver. It's at the corner of Platte and 15, just like the name. It's got 3 stories of mass timber above 2 stories of concrete podium and below grade parking on a 30 by 30 office grid. And you can see the timber structure behind there. And what we did for ThinkWood was to take our mass timber building as constructed, and then also a steel and concrete building built on an identical size and grid, and do comparisons in terms of global warming potential and cost. And just to be clear, as I'm talking about this, we looked at 2 different ways of looking at this. The global warming potential of this building, turns out, is entirely dominated by all the concrete that's below grade. So we look at the numbers for the whole building, but I also took the liberty of looking at the numbers for building that is just above grade, that's mostly timber, because I thought that was interesting as well. But we show both of those in this study.
Hey, Greg, before you leave this slide, there's one question that came in that before you get too far, I think might be really helpful. And for somebody that maybe has not really heard of mass timber, could you just explain what mass timber is and then how it's different from how people might think of wood in general?
Yeah, absolutely. I'm looking for a quick picture. So this shows you mass timber structure. Really, it's like what you would think of traditionally as heavy timber structure, of which you can see a lot around Pittsburgh and the East Coast. A lot of old industrial buildings are this way. The thing that makes mass timber really is that the elements are big enough that they have an inherent fire rating, like a thick log does, in timber. So this is a scientifically proven system that you subject this to fire, and it can basically develops a char layer, and it has its own inherent fire rating. That's really the defining factor. And it's all made of little pieces of timber. Every piece of wood that's in here is actually built up of a bunch of connected or glued together 1x2s. So we're not cutting down old redwood trees or massive forests. It actually comes from 6 and 9 inch diameter trees. Hopefully that's a clear enough designation. Sorry about that. I jumped into my own vocabulary, right? My jargon. So let's look at these comparative studies: a timber building, steel building, and PT concrete building, and look at the global warming potential that we measured with Tally, as Victoria talked about. And interestingly, now I'm looking at the whole building, and I've color coded these bars to show the part that's the gray part is concrete, the blue part is metals or steel, and the green part, which you can't even see, is the contribution from the wood structure. So you see it's totally dominated by the concrete. I get a benefit from my mass timber structure, but it's not much relative to all the concrete we're putting in there. Thought that was interesting. But if I look just above grade, as if I had a structure that was all the timber structure above, here I have a pretty dramatic improvement. I go from GWP, somewhere like in the 35 range up to 110 for steel and over 140 for concrete. Again, still dominated by concrete. That's just the concrete topping on the floors. Okay. Then the question is, what did all this cost actually? If we compare the cost of these different buildings, it turned out in the market that we were comparing, this is a couple of years ago, the steel building ended up at the top of the heap. It was the cheapest one. Concrete was about a 3.25% premium. Timber was a massive 8% premium of the structure over the steel. This is where I tell people that mass timber buildings kind of go to die because they look at these initial numbers. But then we asked, how quickly can we build this building? And it turns out that the mass timber building is the winner. In that case, it can be built 2 months faster than the steel building and 3.5 months faster than the concrete building. And if I fold that into my cost analysis, it cuts that premium not quite in half. And if I look further at the whole building construction, instead of just the structural pieces, it's down to a little less than 2% premium. So there is a premium, a green premium for this building, but it's not very much. It's not as much as people originally thought. If I look at that on a different graph, now I look at mass timber as 100% in terms of GWP and cost and compare the other buildings to that. The steel, 325% more GWP, and concrete, more than 400% more the global warming potential. Cost in this scale looks the same, but I just want to emphasize that 2% I talked about was still in there. There are ways to close that gap. An interesting one I'll throw out to you guys is a company that's just sort of coming out and growing out of their sort of beta period called Aria's Earth. And they work to get premiums to building owners project by project for making embodied carbon decisions that sequester carbon. For this building, in their early analysis, they thought they could make a credit of $155,000. Now I think it would be double that, but it's not enough to close the gap, but it's something. And with that, I just want to end up kind of like Victoria did and just talk a little bit about what you can do and what we've done in our practice. Educate yourself, learn how to measure. As Victoria talked about, this is the key point. Learn the measurement, then learn what the cost premiums are or non-premiums, and certainly innovate. And I'll end again also with Amanda saying our rule 1 at KLNA is start now, no time for rehearsal. So please just do that. Was it that, Beth?
Thanks, Greg. Appreciate that. And appreciate you taking time out to go back and kind of explain. That was probably one of the best definitions of what constitutes the mass timber and how it's unique that I've heard. So thank you for doing that. Let's flip over to Jim Melentine. Jim is a consultant who supports companies, industry associations, and government agencies with their corporate sustainability challenges. Jim teaches graduate design students about life cycle assessment and the circular economy at Thomas Jefferson University, which I think, unless I'm mistaken, that's New Jersey. Is it not, or somewhere on the East Coast? Jim, we'll turn it over to you.
Yep, that's in Philadelphia. So, and now I'm in Colorado. So thank you again for having me. I appreciate it. As Victoria and Greg mentioned, life cycle assessments are a key input to measuring embodied carbon. So just as a refresher for those, what I'm going to talk about here, is geared towards both manufacturers who are making products and trying to reduce the embodied carbon of those products, but also if you're a customer of these products, hopefully this will help you understand better what goes into measuring that, and also maybe change your expectations on what your suppliers might be able to do with this information. So, so just a reminder, a life cycle assessment, or LCA, is the input to the environmental product declaration, or EPD, that is commonly used to communicate the embodied carbon metric. So let's go back to basics and talk about what is in an LCA, because maybe some of you know, maybe some of you don't. And here's just a general image of a manufacturing facility. Maybe this could be similar to yours, maybe not, but it doesn't really matter. We want to talk about what goes into it. So you have all of this information upstream of your operation. So I have some pictures here of pipe and metal sheet and plastic components and microchips, whatever it is that goes into your product. You purchase a certain amount, it's transported to your facility either by truck or train or ship or plane, and all of that takes fuel to do and has impact. And then of course at your facility you use electricity, you probably use some fuel, you use some water, and again, all to generate and get those to your facility has some impact. At your facility itself, you're generating waste, you're generating emissions. Again, there's some impact that goes that goes along with that. And then of course, what comes out of your facility is a product. And the life cycle story doesn't stop there. You also have downstream processes. And so again, there's some distribution that typically happens, and that's going to be different for every company. Maybe your product requires some installation, maybe not, but then the product is used for a certain period of time, and depending on the nature of the product, those use stage impacts can vary significantly. So for example, a product that uses electricity during its lifetime would have more of an impact than a product that just sits in a building and is essentially inert, except for the function that it's providing in the building over that time frame. So but then inevitably all products have an end of life, and whether that means going to a landfill or being recycled or reused, all of that is considered in a life cycle assessment. But the point of me saying all that is that you have data if you've done a life cycle assessment. So, within the inventory that you have quantified inputs and outputs for each stage in that product's life. And there's a good chance that you also have unallocated quantities for facilities where that product is made. So if you have one or more facilities, you have the information available to you on what's going in and out of that facility. And so this table is just a generic table that I'm showing. And actually, this is the same table I use in the course that I teach, that I give to my students as an example. This is what a life cycle inventory might look like. So, across the top, I have different life cycle stages: raw material extraction and harvesting, transport, the actual manufacturing, more transport, some installation, use, and end of life. And for each of those, I've put in some materials and quantities that might be considered inputs and outputs at those stages. So this is an example of data that you have available. But it's not just that. Here's an example of life cycle assessment results that you'll typically see in an EPD. So a breakdown like this, it has different impacts across the bottom, and the one that we're focusing on today is the GWP, or embodied carbon. And then you can see that the different colors indicate different life cycle stages. So in this case, you can see that the upstream raw material extraction and harvesting contributes the most to the embodied carbon of whatever this product is. And here's another way that you typically see these results. You can dig even deeper into a more detailed breakdown and see what specific materials or energy sources are contributing to the impacts. And so you can see that there's more colors here, and individual materials and energy sources are indicated. So you can actually see that how all these different things contribute to the embodied carbon of this product. And by the way, these are both from a published environmental product declaration for Nucor hot rolled steel that you can find on the UL website below. So what's the message? Well, EPDs are valuable as Victoria and Greg have already explained, they can provide some good information and help us reduce our society's and global warming footprint. But I see this way too much. If you put your LCA study on a shelf for 5 years until it's time to renew the EPD, you've really wasted part of your investment and you get a frowny face. So I know that more companies are changing this and how they use their data, and I'm glad to see that, but not enough are doing this. So I've listed here some things that you can use this information to do. And what this is essentially realizing more value from the study that you've already done and the money that you've already invested. So you can use this information to inform the product development process that you use if you're a manufacturer. So you can use the information to model alternative materials, energy sources, logistics, the use profile of your product, different packaging options, and other things as well. And you don't have to be a life cycle expert to do this. If your team doesn't have that expertise, you can make it easy and just use metrics based on life cycle thinking to develop a product development scorecard where you can gauge where the different products in your portfolio fall within the spectrum of sustainability that you've established. You can also use a life cycle assessment to prioritize supply chain improvements. So if you remember that bar chart showing all the different materials and how it impacts the embodied carbon, you can actually focus on the ones that have the largest impact and overlaps with where you have the most influence in your supply chain and make those improvements. You can also evaluate circular business models, which are becoming more popular now. And I have an example later. You can use the information to quantify Scope 3 greenhouse gas emissions and plan reduction targets around your Scope 3. So again, most companies now that are setting greenhouse gas reduction targets are also including Scope 3 in that analysis because they want to have a target that's aligned with the Paris Agreement that Victoria and Greg described earlier. And of course, you can establish a baseline and demonstrate performance improvements over time and use that information to develop credible marketing content that you can use in many venues besides just an EPD. And then you get a happy face.
Jim, just a quick time check.
Okay, all right. I'll try to zip through these examples, but here's an example where I developed a material analysis for product design, where it's just a really high level analysis on some different materials that were going into a product. So aluminum, polycarbonate, power supply, and a cable, so that they could see those impacts. But you could also dig in further and look at impacts for a specific material, in this case, recycled aluminum. You can also visualize it in different ways. So here's a Sankey diagram that shows all of those different levels kind of combined together. And this is the type of information that you can get from a life cycle assessment model. So you can see where the actual impacts are coming from and trace those upstream in the supply chain. You can evaluate circular economy solutions. So here's an example of where a life cycle assessment shows a single-use glass bottle versus a reusable glass bottle that can be refilled and used multiple times, and the impacts that it can reduce because of those multiple uses. You probably have seen this diagram before. This is from the Greenhouse Gas Protocol, showing all of the different activities that are included in Scope 3 emissions. And there's, as you may know, 15 different upstream and downstream categories. And a product LCA might not have all of those categories, but it can serve as a starting point and a consistent approach for your environmental sustainability reporting initiatives. The graph on the left shows an example of Apple reporting their carbon impacts for different products. This is an old example, so it's not available on their website anymore, but they've actually matured this program. And on the right-hand side, you can actually see it on their website now. You can download environmental profiles for all of the products that they offer. And why does Apple do this? It's not complying with any laws. Most LCA activity is driven by customer requests. It's voluntary, but it also helps your brand reputation with an appeal to a growing segment of the population. And who use environmental responsibility as an input to purchase decisions. like I said before, you can also demonstrate improvements over time. So here's an example of Kohler. They make toilets, and they've actually established a baseline and made some improvements in their process and used that life cycle assessment to demonstrate the improvements that they've made over time. And they can use this in their marketing. So it tells a really good story. So in summary, sorry I had to rush through that last part, but your LCA has lots of useful data, so you should use it. Maximize the value of your LCA beyond an EPD. So improve your product development process, make supply chain improvements, investigate different circular business models, improve your scope 3 greenhouse gas accounting, and improve your marketing and communications. So I appreciate your time today, and I think now we're ready to take questions. So thank you.
That's great. So I think, Sarah, if you want to pull up the Menti questions so we can re-engage our audience members, and if the panelists could all come back on screen. Let's see, I've got Victoria, I've got Jim, there's Greg. Terrific. So I think we'll go to the Menti question. While we're doing that and transitioning to that, and you guys are thinking about that, Dr. Schroff from Duquesne added into the chat a comment that the book that was referenced in the presentation, Bill Gates' book, is available free and online. So I thought that was a great ad. So thanks, Robert, for dropping that in. So here's the Menti question. What might help you to incorporate embodied carbon in your decision-making? Carbon tax, okay. Super supportive of behavior change, right? If we want to try to go after different decisions, that's always a good, powerful way to do that. I can't type in myself. Maybe Sarah, you could add for me something along the lines of tools. The tools that Victoria mentioned are great, but they need to continue to become more and more robust. So I think decision-making gets easier the more confidence we have in the available tools and the information in the tools. Client-driven, code zoning. Yep, a lot of code conversation here. So maybe we could start with a couple questions that have been put into the Q&A in the chat. And I'll start with Amy Curtright had a question. Jim, I'll pitch this to you. And her question is, what's the potential for low embodied carbon materials to improve life cycle emissions for retrofits? Here in Pittsburgh, we have a lot of retrofits. So as these answers keep coming in, Jim, maybe you could kick us off on an answer around that question.
Yeah, sure. That's a good question. And I think I'd say that the value is essentially the same. It's just that you probably have a different focus, and so you have to shift your focus. So as Greg described in his presentation, a lot of the impacts in a building are from the structure. And so if you're building a new building, rightly so, you should pay attention to that because there's a lot of concrete and steel, and those have impacts. If you're reusing that building, then that's a great first step in reducing embodied carbon impacts, because you don't have to, in most cases, rebuild the structure. Maybe you're augmenting it in some way, but for the most part, you're focused on the other materials, the finishes and furnishings of that space. And so you can still use the same information for that focus. So there are lots of environmental product declarations out there for those types of products. And I would say that you can use the same strategies for that.
That's great. Thanks, Jim. And then there was a question, Greg, more directly, I think, to you from Tim Nuttall. And the question is not directly related to embodied carbon or global warming potential, but the building that you had in your talk featured a glass facade. How does glass relate to embodied carbon versus other materials, i.e. wood, that also have benefits like lower bird strikes?
I think that's a great question. It could actually go to any of the three of us. We could probably expand on it a lot, but I'll start with the fact that the life cycle assessment that I did was only the structural materials. It was the concrete, the timber, the foundations, everything that's holding the building up. And it did not expressly include the building envelope. But a complete life cycle assessment should. That's what Victoria was calling a whole building life cycle assessment. and why we end up working together, because she can help with that that part of the analysis. And I think what you'd find actually from an embodied carbon point of view, forgetting bird strikes for the moment, that glass doesn't show up all that well in that analysis, right? And so if you're looking, I'll let Jim and Victoria correct me if I'm wrong, but I think that there'll end up, if embodied carbon is a top design driver, that will encourage you to use different kinds of building envelope systems than all glass systems, just because of the carbon footprint.
Victoria, did you want to add anything to that?
Oh, Greg put it really well. I will only add that it is at the end is a trade-off, right? With everything, like when you're looking at a entire building as a system. So glass is not only, it might not only be not as beneficial for embodied carbon reductions, but also from a thermal perspective too, the R value of a glazed, completely glazed building will be definitely affecting the energy performance of another type of building assembly for the enclosure. So there's always like trade-offs that should be analyzed. And I'm curious to hear Jim too, because from the product perspective, I have heard that there is a lot of issues about sand, like there is like depletion of sand. So Jim, do you know more of that, like from the embodied carbon perspective?
This is difficult because architects and designers love glass, right? They love to cover buildings in glass because we all love natural daylighting. We love the views, and that's a natural human desire. But it comes with both embodied carbon impacts and the operational impacts from losing all that thermal energy through the glass. And so you can, and you're right, glass and aluminum for curtain walls, they both have some pretty big impacts, and you can help lower those impacts by doing things like using recycled aluminum for the frames. I don't think companies tend to use recycled glass very much because they need a really high quality glass to create a uniform view, and so that's really difficult. But yeah, as Victoria mentioned, sand is in higher demand these days, and it actually does have some significant impacts beyond just embodied carbon. There's other environmental impacts as well. So
Thank you.
It's never easy. I was just going to say, because daylight also helps with operational energy, right? So it's always a trade-off.
Sure.
It's a balance. It's a balance for sure. But that's where some of the technology we had today benefits these choices, right? We can now simulate and anticipate how a building's going to perform before we have to necessarily invest in it. So we should be able to get better at those trade-off choices. Question for you, Victoria. When we asked the Menti question, what came through 3 or 4 times was around code. What are you seeing in the way of code, and is anybody doing it well?
Well, California is doing it well, apparently, or they are trying. There's there are cities, and they're statewide. I think California and Colorado have the Bike Clean legislature that passed, and right now they are leading the research piece, because the regulation, what requires you to do is to provide EPD for certain products. So it is kind of like building up. Again, we cannot reduce what we cannot measure. So if we don't have enough data behind to know what can we do to reduce farther, then we cannot really say, okay, 20% or 40% is a good threshold. So some people have asked me before, like, what is a realistic threshold? I'm like, so far, I have not, if you don't use wood in your project, at Greg's example, there's very little, like no more than 20% reductions in a whole building LCA I have seen so far. So it is very difficult to get reductions if you don't follow if you don't have all the data behind. So I think all these regulations and codes are going to help the industry to keep moving forward, and I will encourage you all to also again like have these conversations and talk to this at city level, at a state level, with anybody that you can to propose these type of bills and
So in order
regulations.
to do the measure, I'll flip to Jim. In order to do that, you can't produce what you can't measure. These EPDs become critical. So are you seeing that an acceleration in how companies are thinking about putting forward these product declarations?
Yes, probably not accelerating as fast as we need, but yes, companies are maturing in how they present this information and use it. So, you know, in the last version of LEED, which is a green building system for those not familiar with it, they actually started rewarding companies that demonstrate improvements in their product performance through EPDs. Whereas, you know, up until very recently, as long as they just disclose the impacts, that was good enough. And now companies are shifting toward more demonstrating improvements through that mechanism.
And then we have one question, Victor, I'm going to pass this back to you. How do carbon credits and offsets come into play with the analysis conducted on embodied carbon?
I think the three of us can answer that question too, and I want Greg and Jim to maybe go into the weeds on some of the topics. But so from the product perspective, Jim can explain a little bit more, but like offsets are normally like if you buy RECs for your electricity on your manufacturing, normally are not included in the environmental product declaration. So there are some things that Jim can touch more on how to do it at product level. As a whole building LCA level, there is not really a carbon credit or carbon offset like very tangible at this moment. There are some companies out there maybe developing things, and one that Greg can speak up to it called Orias Earth, which is for buildings that will use wood, and you can get kind of like a carbon offset or a carbon incentive by using wood and reducing the embodied carbon. But normally you will do the analysis on reductions without including your offsettings. Besides for wood, you can include the biogenic carbon as well and increase your embodied carbon reductions.
That's great. And then we had one last one come in, and I'm sure Gina wants to close this off. We're coming dangerously close to our time, but I don't want to drop this one either. So between Greg and Jim, either one of you, if a picture can be powerful to changing people's mindsets, can the panel recommend good examples of or ways to visualize CO2 and embodied carbon in meaningful ways for users, occupants, or decision makers?
Man,
That is a tough one.
that's a tough one. You know, there's a number of things that we do because I'm focused on wood. I mean, I just want to emphasize that all the different materials need to be paid attention to, right? From concrete to whatever. But I often think about visualizing the amount of timber, like that building that we built. We can, it's not a picture, but it's a visualization that you can grow all of the timber needed to build that building in a matter of a couple of hours in the forest that it was cut from in Quebec, as it happens. So there's ways to connect, you know, what you're doing to real life scenarios that help people imagine. But I have no great picture for you right now.
Yeah, so knowing your audience is key, right? So that's a really good question because different people will have different levels of understanding. Some people have no idea what a kilogram of CO2 equivalent is or what that means. And for those folks, what I've seen a lot is people turn to the EPA's carbon equivalency calculator, which they have online. It's an online tool. You can essentially plug in the number, the kilograms of CO2 equivalent, and it spits out what that means in things that people understand, like miles driven or trees planted or things like that. And people will use that as a stand-in for their results so people can visualize it better. So that might be a good first step.
It's a better answer.
That's great. Thank you. And thank you to the panel. Really, it was such a powerful conversation. And thanks to Gina and Sustainable Pittsburgh for bringing this type of programming to us here in Pittsburgh. It's something we're all thinking about and trying to figure out how to advance. So it starts to get us up the curve. So Gina, I'll pass it back to you.
Great, thank you, Beth. You did a great job. Our presenters were fantastic. Thank you, and really appreciate the wonderful questions from the audience. All of these next steps are resources that we can provide, or we'll be directing you to in an email to follow up on this event that will include the recording. It'll also, you'll be able to access all of the information here, so I hope that you can take advantage of that. If we go to just the next slide, we'll skip to. Just want to thank again Beth, Victoria, Greg, Jim, for being with us and sharing their expertise. Really wonderful. Thank you. We also want to thank Covestro again. Thank you all for being with us. We invite you to support our work by making a donation to Sustainable Pittsburgh in any amount. We always appreciate it. And with that, we will let you get back to your day. Thank you so much. And I look forward to seeing you again at a future event. Thank you.